In this episode, we're going to compare layer 2 and layer 3 devices. I'll show you how to do it, and we'll talk about the concepts along the way. We'll use various commands to examine 3 different switching topologies and compare the similarities and differences between the switches. We'll also compare the routing table of a router with that of a layer 3 switch. We'll be comparing layer 2 and layer 3 switches and comparing a layer 3 switch and a router. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 11.5.1. Compare layer 2 and layer 3 devices. I have the Packet Tracer file opened up. On the left side, I have our work area. I have our topology. That's where we're going to go ahead and look at our devices here. On the right side, I have our instructions. The way bottom right is the Packet Tracer activity window that opens up when you open up the Packet Tracer file. It has all the instructions. In the upper right is a Word document of all of those instructions. Reason I have the Word document, there's lots of questions to answer. Word document will allow me to save those answers. Our objective, we're going to compare some layer 2 and layer 3 switches in part 1. And part 2, we're going to look at a layer 3 switch and a router. Coming down here to step 1, compare layer 2 and layer 3 switches. Step 1A, examine the physical aspects of D1 and access switch 1. D1 is right here towards the upper left. Access switch 1 is on the far left. We're going to be comparing these two switches right here to each other. So those are the two switches we're going to compare. So we're going to examine the physical aspects. Each individual switch has how many physical ports? Let's start by looking at our access switch 1. This is our access switch 1. I'm going to click on access switch 1. I'm going to bring this up, make the window a little bit bigger going right to left, and I'm going to click on the physical tab right here. I'm going to go ahead and click on the physical tab. We can do a zoom in. And here's what the switch looks like. We have our status lights over in this area. On the right side, we have our ports and configurations. We can tell this is a 2960 switch because it says 2960 right up here on our switch. We have 24 ports in the main area, and then a lot of people call this the uplink area. In the uplink area, we have 2 switches there. 24 plus 2, that gives us 26 ports. So on the 2960, the 2960 has 26 ports. Then let's look at the other switch. I'm going to go ahead and minimize this. I'm going to look at D1. D1 is right here. Click on that. Slide this up. Make the window a little bit bigger. Going right to left. I'm on the physical tab right here, and I'm going to click on zoom in once. That'll give me a little bit better view. Here's our status area with the different lights. If I scroll over to the right side, oh, here, these are power supplies. You can swap those in and out. Over here is our ports. This is what our ports look like. Here we have, in the main area, we have 24 ports. These are fixed ports. Over here we have 4 modular ports. These are 4 modular ports, and these accept SFP module. SFP stands for small form pluggable. So we have 24 fixed ports here, and then we have 4 modular ports here that accept SFPs. The 3560 has 24 fixed ports and 4 modular ports that accept SFP modules. SFP, there we go. How many fast Ethernet and gigabit Ethernet switch ports does each switch have? Okay, so how many do they have? How many of the fast Ethernet and gigabit Ethernets do we have? I'm going to minimize this. I'm going to go back to access switch 1 here. Now I'm going to go back into the CLI. I clicked on the CLI and hit enter, type in enable. From here, we can do a show IP interface brief. I hit spacebar to give me all the information, but on our access switch 1 here, the 2960, we have fast Ethernets 1 through 24, so it has 4 24 fast Ethernets, and then 2 gigabit Ethernets. So the 2960 has 24 fast Ethernet ports and 2 gigabit Ethernet ports. Okay, I'm going to minimize our ASW1, go to D1, our distribution switch 1. I'm going to go into the CLI and I'm going to enter in that same command. So type in enable to get into privilege exec mode, and now do a show IP interface brief. Oh, I spelled show wrong. Now, to correct, okay, once again, this is how the Cisco IOS works. If you do something wrong, it will let you know. If you do something right, no news is good news. But I did something wrong. It says I have invalid input detected here at this little caret sign. Here's the caret sign. So somewhere in this area, I have a problem. Well, I spelled IP right. If I look before it, I spelled show wrong. I put SHP in there. It should be SHO. So what I did is I hit up arrow once, left arrow over, make it into SHO, and I hit enter, and we have our information being displayed. So on the 3560 D1, we have 24 gigabit Ethernet in our fixed ports. These were the fixed ports. Then here we have the modular ports listed at the end. Now we can tell it's on a different plane because the middle number right here is different. The fixed plane here is the 0 is the middle number. In the modular plane, that's where we have the 1. And so we have 24 gigabit in our fast Ethernet, and we have 4 modular ones that are all gigabit. Okay, the 3560 has 24 fixed gigabit and 4 modular gigabit ports. To get the transmission speed here, I'm going to minimize our D1 switch, go back into our access switch 1. I'm going to issue the command show interface. And specifically, I'm going to go into our fast Ethernet, so F0/1. When I list this out, it's going to give us some information. It's going to tell me that my protocol is up and up. It's going to give me my MAC address. Then it's going to come here and give me this BW number. This is the bandwidth. The bandwidth here is listed. We've got 1 followed by 5 zeros, or 100,000 kilobits. Translate that into megabits per second. That's 100 megabits. So the fast Ethernet. So fast Ethernet is speeds up to 100 MBS megabits per second. If I go and do a show interface gig 0/1, because that is, whoops, that is right here, gig 01, we'll get that information for the gig Ethernet here saying our protocol is up and up. Here's our MAC address. And then down here is the BW number again. The BW number lists 1 with 6 zeros, or 1 million kilobytes, If we turn that into megabytes, that is 1,000 megabytes or a gigabit speed. And so gigabit is 1,000 MBS, megabits per second. Are either of the two switches modular in design? Yes, they are. I'm going to minimize the ASW or our access switch 1, go into D1. I'm going to look at the physical locations. Once again, these SFP ports here, these are modular ports. We can put SFP, small form pluggable modules in there. So yes, they are. The 3650 is modular. So the 3650 is modular. I guess I got to answer the question, are either one of these are modular? Yes. The 3650 is modular. The switch ports of the 3560 have been configured as a layer 3 interfaces by entering the no switch port command on interface configuration mode. This allows technicians to assign IP addresses and subnet masks to the switch ports in the same way they are configured on a router interface. What is the difference between a layer 2 and a layer 3 switch? Well, a layer 2 switch only looks at layer 2 information at MAC addresses. A layer 3 switch does all the functions of a layer 2 switch, plus it does the routing. It looks at layer 3 addresses and can route those IP addresses. Okay, so a layer 2 switch makes forwarding decisions based on layer 2, which is the MAC address. Switch port on layer 3 switches can be configured as interfaces with IP addresses. And once again, those are layer 3 addresses. The switches can also be configured with routing protocols like a router. What is the difference between a switch's physical interface and a VLAN interface? Well, one is physical. You can plug that cable into those physical interfaces. The virtual one, you can't plug anything into. But it goes a little bit more beyond that. That physical interface you use to connect to the end devices. So that physical interface on a layer 2 switch doesn't get an IP address, but that VLAN interface, you can turn that into your SVI, your switch virtual interface, to allow you to connect in remotely to manage that device. Okay, so our answer here, a switch's physical interface is used to physically connect end devices to the network. A switched virtual interface, once again, that's called our SVI, is used to configure the switch with an IP address so that it can be managed remotely. Okay, you gotta take care of some spelling errors. At what layers do the 2960 and the 3650 switches operate? The 2960, I'm going to minimize D1. Our 2960, here's this access switch. Just these ports on here. It doesn't do any layer 3 stuff. It just deals in layer 2. That's the MAC addresses. And so here, the 2960 operates at layer 2, and then our distribution switch, that's the one that has these and the modular ones, but we can also turn these, any one of these ports, into a routed interface, so that operates at layer 2 and layer 3. So the 3560 operates at layer 2 and layer 3. Issue the show run command to examine the configurations of the D1 and access switch 1 switches. Do you notice any differences between them? Okay, let's go ahead and do a show run here on our access switch 1. Go into our CLI. I'm going to hit Command C because right now the command I was in, the show interface, says it has more information to display. Control C just terminates that show command right there. I'm going to issue the show run command. Here's all the information. We got the host name. We have all of our ports configured. We have our VLAN interface, our switch virtual interface. We have a default gateway so we can remotely connect from a different network on there. Here's our line consoles, line VTYs. And then let's look at our distribution switch. Back on our CLI tab, log in, type in enable, and do a show run from here. Here we have our host name. We notice we have IP routing turned on. That's different from the other switch. We have, here's our ports. Notice the ports here have 3 numbers after them because of the modular aspect of the switch. Here we have a gig Ethernet port, and it's got an IP address in there. So we've turned routing on those ports. We did a no switch port on these. We don't have a VLAN address on them because we don't need one, because these interfaces have IP addresses, so we can connect into those IP addresses remotely. And then here's our console and our VTY connections. So lots of differences here. Okay, so on D1, do you notice any differences? Yes, there was several of them. Yes. D1 ports are all gigabit Ethernet. Now, how did we notice that? Notice as we did the show run here, it gave us all of our interfaces. All of these are gigabit Ethernet ports. I'm going to shrink this down actually. Access switch 1 here. I'm going to shrink down a little bit here so that we can kind of show them side by side. On our access switch 1 here, we have fast Ethernet. And if we go down here, the last 2, what we call uplink ports, typically, those are gigabits. So D1 ports are all gigabit Ethernet, while the 2960 has mostly fast Ethernet ports and 2 gigabit ports. And those gigabit ports, those are, like I keep saying, intended to be uplink ports, and you typically hook those to your other internetworking devices, to other routers, to other switches. Normally you wouldn't hook an end device up to that. And those 2 gigabit ports, they're intended for uplink ports. back on D1, noticing once again our ports are using that modular, the module number, the stack, or sorry, no, it's what stack it is, what module, what port it is, while the ASW1 or access switch 1 only uses module and port number. So D1 uses stack slash module slash port format. D1 also has, like we pointed out here, these aren't switch ports. These are routed ports. We can use these just like an interface on a router. We did the no switch port on them. And so we can put an IP address and we can route these to an entire different network. D1 has switch ports that are configured with the no switch port command and show an IP address and mask configured on, and those were configured on G1/1/1 and G1/1/2 ports. Also, D1 has IP routing enabled with the IP routing command. And once again, to see that, we can scroll up here, and that was right here. That turns routing on this layer 3 switch, on this 3650. Try to display the routing table on D1 and access switch 1 using the show IP route command. What do you think the command, why do you think the command does not work on on the access switch 1 but works on D1? Why do you think the command does not work on access switch 1 but works on distribution switch 1? Okay, so show IP route command, access switch 1 here. So show IP route command comes back and says invalid input detected. Okay, so it's saying right here's the problem. Let's go ahead and enter in show IP, put a space and then question mark. And notice there's nothing to do with a route here. We have ARP, which is all MAC address. We have access lists. We have DHCPs. We have some interfaces. We have SSH. Nothing with routing there. If we enter in that same command here, show IP route, it gives us our IP routing table. Now, why is that? Well, looking here, switch 2 is just a layer 2 switch. It only deals with MAC addresses, doesn't worry about anything at layer 3 or higher, which is our IP addressing, which is our routing table. On D1 here, distribution switch 1, layer 3 has been enabled. Routing has been enabled. We put IP addresses on some of the interfaces to allow it to route to networks that are connected to that. We have actual routing turned on here on this device. Now, to answer our question, it works on D1 because D1 functions on layer 2 and layer 3, which allows it to function as a layer 2 switch, but at the same time allows it to route packets and make forwarding decisions based on layer 3 information, which is our IP addresses that conventional layer 2 switches cannot. And then make a spelling correction. And the other thing here is we need to talk about here why our ASW1, our access switch 1, can't do it. ASW-1 is a layer 2 switch and therefore does not have a routing table. That takes care of step 1. On to step 2. In the past, switches and routers have been separate and distinctive devices. The term switches was set aside for hardware that functions at layer 2. Routers, on the other hand, are devices that make forward decisions based on layer 3 information. They use routing protocols to share routing information and communicate with other routers. Layer 3 switches, such as the 3650, the one we're using here, can be configured to forward layer 3 packets. Enter the IP routing command, IP routing, in a global configuration mode allows layer 3 switches to be configured with routing protocols, which gives them some capabilities of a router. Although similar in some ways, layer 3 switches are different from routers in many other aspects. Open up the physical tab on D1 and R1. Do you notice any similarities between the two? Do you notice any differences between the two? Okay, I'm going to minimize all these windows right here. What we're looking at here is D1 and R1. So right here is R1, router 1, and here's D1. So we're going to look at the physical differences between D1 and R1. Click on D1, click on my physical tab, expand this out a little bit so we can see it. I'm also going to click on R1. Click on the physical tab, expand that out some, do a zoom in. See if I can layer these two so we can see these similarly. Okay, so we do have, we're able to show you some of these back and forth. Actually, I'm going to layer these a little bit differently. There we go. We have the router up on top here. We have R1 up on top. We have D1 down here. Here's the backside of R1. We notice we have power. We have a power cord coming in here. We have our console connections. We have an auxiliary port here. We have some gigabit Ethernet ports here. Looks like we even have some modular ones. And then over here we have some modular faceplates, meaning we can put different modules inside of this device. Here we have our D1 switch. We have our status lights. On the back we have a console port. We have some fans. We have a bunch of Ethernet ports here. We have some modular SFP ports here. Now, do we notice any similarities or differences? Well, they both have a console port. If I scroll back over here, here's our console port on the D1 switch. Here's our console ports on router 1. So they both have console port. They have USB ports. Right here's the USB port. Right here's the USB port on the switch. Okay. And we do have gigabit Ethernet ports. The router has some here. The switch has a whole bunch here. And so they have gigabit Ethernet ports. Both R1 and R2 are modular. So we can put modules into R1 right here. On D1, these are modular here. We can put SFPs into this slot. Both are modular. Now, with these modular ports, we can put in different interfaces. We can put more gigabit interfaces. We can put serial interfaces, T1, fiber connections. Down here on D1 layer 3 switch, these are modulars, and we can put in different types of gigabit Ethernet interfaces here. We can put copper, we could put fiber, SFPs into there. R1 has serial interfaces, where D1 only has gigabit Ethernet interfaces. And so that's a difference. So R1 has serial and asynchronous interfaces, while D1 has only gigabit Ethernet interfaces. Asynchronous. D1 can accept either copper or fiber depending upon what SFPs are here. On R1, depending upon what modules are put in here, it can accept different types of connections. D1 can accept copper or fiber depending on what type of SFPs are inserted. R1 can accept different types of connections depending on types of modules inserted. And one of the last big differences here between R1 and D1 has a lot more gigabit Ethernet, because once again, these are intended for your end devices all to connect into. And so it has a lot more Ethernet interfaces to connect into. D1 has many more gigabit Ethernet interfaces than R1. Issue the show run command and examine the configurations of R1 and D1. What differences do you see between the two? Let's go ahead. I'm going to shrink these down to show us our show runs back and forth. D1's on the left, R1's on the right. Go back into my CLI, log in, type in enable to get into privilege exec mode. Let's do a show run. Let's type out show run correctly. Spacebar down, get all the way through. I'm going to do the same thing here on R1. Enable, do a show run. Spacebar all the way down, allows me to scroll back up. So I'm scrolling back up to the top. What do we see that's different? Is that what we're looking for? What differences do you see between the two? As we look through here, we can see, well, the host names are different. Do you have some routing? Gigabit Ethernet 010 on the switch. These are access ports here for end devices. I'm going to scroll down here. But when we look here at gig 111 and compare it to gig 000, notice that we even have the same IP addresses, but they're on different interfaces. So it's configured with the same IP addresses, but different interface. Look at on D1, look at gigabit Ethernet 112 that has 192.168.11.1. On router 1 over here on the right, interface gig 001, that has IP address of 192.168.11.1. And so they're configured with the same IP addresses, just they're assigned to different interfaces. R1 and D1 have the same IP addresses configured on them, but on different interfaces. Which command allows configuration of D1 with an IP address on its physical interfaces? When we look at D1 here, which command allows us to turn one of our interfaces into basically a router port where we can connect it up to a network and we can route information in and out of that port? The command to allow us to put an IP address on that interface right here is the no switch port command. It's the no switch. You have to be in the interface, but it's the no switch port command. It's the no, and I'm going to put it in quotes here, the no switch port end quotes command. Use the show IP route command on both devices. Do you see any similarities or differences between them? Okay, show IP route on D1 here gives us some information. Let's go ahead and do that command here on R1, show IP route. A little bit of difference here. We can see that we do have C, meaning that's a connected network, and then we do have the L, meaning that's our local address of that connected network. And we have two of those networks. It's saying that network 192.168.10.0/24 is directly connected. Here on D1, it says the same thing, that it's directly connected. So there are some similarities here. To answer our question, the codes are the same, except the router has an L code for local. This is a link that is configured on the physical interface of R1. The switch routing table does not have this code. Both devices display the same network in their routing tables. Go back up here, do a little spell checking. Now analyze the routing tables of R2 and D2. R2, D2. What is present now that was not present in the configurations of R1 and R2? Right here this is D1 and R1. These are our routing tables, so we have directly connected networks. I'm going to go ahead and minimize these. Now they want us to look at R2 and D2. That'd be these two devices right here. I click on R2, bring that up over here. We want to go into privilege exec mode. We type in enable and then show IP route. Show IP route. Display some information. Let's go ahead and do D2 quickly. On D2, let's go ahead and log in, type in enable, and then show IP route. Here's our routing table. I'm going to bring up R2 again. Here's our routing tables. We do have I'm actually going to switch these around because that's what it was on our last screen. Switch was on the left, router was on the right. On the left, we have some directly connected networks, but we also have this O network. This O network, if we look at our codes, O stands for OSPF. So we learned about a network through OSPF right here. If we look at R2 right here, we have our directly connected networks. But we also have some O networks. Once again, O is OSPF. We learned about two different networks through OSPF. So what is present that wasn't present before? They both have OSPF configured, and both are learning networks from one another. Which network is in the routing table of D2 that was learned from R1? So in D2, which network here was learned from R1? That would be this network here, the one that has the O by it. This network was learned from R2. And that's the 1.1.1.0/24 network was learned from R2. Okay. On to B. Verify that each topology has full connectivity by completing the following tests. Okay, I'm going to minimize R2 and D2. Ping from PC1 to PC2. That's these two PCs right here. So I'm going to go into desktop of PC1, open up my command prompt, type in ping, and then I need the IP address of PC2. Or if I mouse over this right here, PC2 has an IP address of 192.168.11.10. That's on that little pop-up that shows there, and as you see, it says fast Ethernet, and then it says up, then 192.168.11.10. So from PC1, I can ping that 192.168.11.10. Hopefully we're doing an ARP lookup here. Fail on the first ping. There we go. First ping request timed out because it had to do some ARP lookups. I'm going to repeat that command just to make sure it works. So up arrow once, hit enter. All four pings are working. I'm going to go ahead and minimize PC1. Next one we have to do is ping from PC3 to PC4. That's these two PCs right here on PC1, or sorry, PC3. Go to desktop tab, open up my command prompt, ping. Now we need to get the IP address of PC4. If I click in the window, mouse over PC4, it'll tell me that IP address is 192.168.11.10. Same IP address. Well, how can it be the same IP address as PC2? These are completely separate networks. They just happen to be drawn separately. So this is a different network than this one. That's how PC2 and PC4 can have the same IP address, 192.168.11.10. So let's go ahead and put that in there. So ping 192.168.11.10. Because it's a different network, I'm guessing we're doing an ARP lookup again. Okay, 3 out of 4 passed. I'm going to repeat that command. Up arrow, hit enter. All 4 worked. That's looking great. I'm going to minimize PC3. And the last one we need to do is ping from PC5 to PC6 and 7. That's these 3 PCs right here. So from PC5, we're going to ping PC6 and then PC7. I'm going to open up PC5, go to my desktop tab, open up my command prompt app, type in ping. Need to get the IP address of PC6. I click in the window here, mouse over PC6. 192.168.10.10 is PC6, so that's the IP address we have to ping. 192.168.10.10. Back on PC5. 192.168.10.10. Probably have to do an ARP lookup here. First one should fail, next three should work. Repeat that command, up arrow, hit enter. All four pings work, so we got connectivity there. And now we have to ping PC7, so I typed in ping. Come over here, get the IP address, click in the window, mouse over PC7. It tells us our IP address is 192.168.11.10. Once again, same IP address as PC4 and PC2. Because they're completely separate networks, that's fine. So 192.168.11.10, back on PC5. Go ahead, type that in, 192.168.11.10. Might have to do an ARP lookup. Excuse me. First one failed, three succeeded. Just repeat that command again. All four work. We do have connectivity on all of our networks. Which device is used to provide communication between networks? Now, each one of these, for the left network right here, if we look here, this is one network, this is another network. What provides us communication between them? That would be this layer 3 switch. Here in the center setup, this is one network, this is a second network. What provides the communication between them? That would be this router up here. And on the right setup, this is a network, this is a network, this is a network here, and this is actually another network. We have 1, 2, 3, and 4 networks set up here on this right setup. What provides the communications between them? Well, it's a router, and it's also this layer 3 switch here that does routing. So what device is used to provide communication between the networks? That would be a router and layer 3 switches. Why are you able to ping across networks without there being a router? What we're looking at here is this first setup. Why were we able to ping from the left network, the one where PC1 was on, to the network where PC2 was on? They're separate, different networks. They have different network portions in their IP addresses. Why were we able to ping between them? Because this is a layer 3 networking device. This is a layer 3 switch. Switches traditionally didn't allow you to go between networks, but now that we have layer 3 switches instead of the traditional layer 2 switches, we can turn these ports into routing ports. We can have this layer 3 switch do some of the functionality of a router, like route between networks. Okay, so let's go ahead and type our answer in. Multi-layer switch can provide route between networks as long as it is configured with an IP address and has IP routing enabled. IP routing must also be enabled if you plan to run routing protocols such as OSPF on the switch. The no switch port command must be enabled on the interface in order to assign an IP address and subnet mask on the switches physical interface. Do some spell correcting. There we go. And the last one. We say that routers are layer 3 devices and conventional non-layer 3 switches are layer 2 devices. However, we can assign IP addresses to management SVI interfaces of a layer 2 switch. How is this possible if the switches are layer 2 devices? Looking at these access layer switches here, these are all layer 2. We can't do any routing, but yet we assign IP addresses to them. Those IP addresses don't go on a physical interface. They go on those virtual interfaces, on the switch virtual interfaces. That allows us to remotely manage into these from anywhere on your network to go in and do configurations. You can remotely manage that. So our answer here is managed layer 2 switches such as the 2960 have an additional, sorry, not an additional, has an embedded server that can be reached over layer 3, your IP addresses. The server enables Telnet, SSH, or HTTP access to the switch from across the network so that the switch can be remotely managed and configured. It is useful to think of this functionality as separate from the data forwarding function of the switch, which exists at layer 2. That was Packet Tracer Lab 11.5.1, compare layer 2 and layer 3 devices. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.